Example 3 here, I think that says a 3. Example 3, again, just one step in a more complicated direction. Okay. Solve this system by substitution. Well, we've got some ugly and nasty fractions. Okay. So determine the LCD, lowest common denominator, for equation 1 and equation 2. Multiply the entire equation by that number to eliminate the fractions. Then use those equations to substitute and to solve and substitute. Okay? So the first thing we need to do is write equivalent equations with integer coefficients. We want to get rid of those fractions. We could work with the fractions, but fractions cause a lot of grief. Okay? So the first step we need to do is multiply each fraction by its common denominator, or each term in that equation by the common denominator of all of the terms. So let's look at equation 1. What is the lowest common denominator for equation 1? The lowest common denominator for equation 1 is 12. So I need to multiply each term in this equation by 12. Lowest common denominator for equation 2 is 3. So I multiply each term in that equation by 3. And when we do that, you'll see that all the fractions will reduce. And we haven't really changed the equations at all. We've just increased them by a factor of 12 here, by a factor of 3 here. So we're not changing them, we're just making them bigger. Okay, so I take my first equation, 3 over 4x plus, no, is it plus? Yeah, plus 1 over 2y equals 12. No, equals negative 7 over 12. I said that my common denominator was 12, and I need to multiply each of these terms by 12. Not 2, but 12 by 12 by 12. What does that get me? That gets me 36 over 4x plus 12 over 2y equals negative 84 over 12. And what happens to all these fractions? Well, 36 over 4 reduces to 9, 12 over 2 reduces to 6, and negative 84 over 12 reduces to negative 7. So now I have a new equation without any fractions in it, much easier, much simpler to work with. Okay. I do the same for my other equation. X minus y is equal to negative 4 over 3. Common denominator was 3, so I multiply each term by 3. That's going to give me 3x minus 3y is equal to negative 12 over 3. The only fraction to reduce is the last one. Okay. Gives me negative 4. Now I choose one of those equations and rearrange. This one looks a little bit simpler to work with, so I'm going to rearrange this. I'm going to solve for one of these variables. So I take my equation, 3x minus 4y equals negative 4. I'm going to solve for x, so this is going to be plus 4y, which gives me 3x is equal to 4y minus 4. Did I mess something up? I did, because it's not a 4y, it's a 3y. 3. This should be a 3. This should be a plus 3y. And this should be a 3y. Minus 4. There we go. Now I'm going to divide by 3. Divide by 3. Divide by 3. X is equal to, those will cancel. These will cancel. Y. Oh, but unfortunately, we are stuck with an ugly, nasty fraction anyway. That's unfortunate because we need to do the rest of our work using an ugly fraction. But, well, you should be able to do it. So now we take that and we substitute this in for x into our other equation. Now the one that we've rearranged and rearranged and figured out to be simpler was this one. So I take my 9x plus 6y is equal to negative 7, and I substitute this in for x. Whoops, where are we here? this in for x, y minus 4 over 3. 9 times y minus 4 over 3 plus 6y is equal to negative 7. And then start doing some math. Bomb this in. Gives me 9y minus 36 over 3 plus 6y equals 7. Oh, that worked out nicely because 9y minus 36 over 3 is 12. No more fraction. So we get 15y minus 12 is equal to 7. Add 12. 15y. 15y is equal to 22. Nope. Something's wrong. Oh, it's a minus 7. Minus 7. Minus 7. Minus 7. Because that shouldn't be 22. This should be 5. Divide by 15. Y is equal to 5 over 15, or 1/3. So now we take that and we substitute back into any one of our other equations. I'm going to go into the second equation. It's always a good idea, if you can, or want to, or how comfortable you are, but you should substitute back into original equations. Just because you're really not sure if you may have messed something up. And if you have, well, if you put a messed up value into a messed up equation, you're going to get a messed up answer. So I always try and go back to original equations when I can, or where it's nice and convenient. So I am going to take my y is equal to 1 over 3, and I'm going to put it back into my original equation. My original equation, if I can erase that line, of x minus y is equal to negative 4 over 3. We said that y is equal to 1/3. X minus 1 over 3 is equal to negative 4 over 3. I'm going to add 1/3 to get rid of this. Add 1/3 over here. So cancel. X is equal to negative 4 over 3 plus 1 over 3 is negative 3 over 3, or negative 1. So there is my solution to this system, and it would be negative 1 and 1/3. Yes, you can have fractions as solutions. Yes, it wouldn't necessarily be the funnest thing to do. It isn't the funnest thing to do. It gets a little complicated. This would be extremely difficult to do on a graph. That's why we learn how to do algebraic solving of systems, just so that when we run into this problem, we can do it algebraically as opposed to graphing, because you would not be able to get that information off of a graph unless your graph was super detailed and you had these huge grids that you could plot some points on. Okay, 7.4 assignments listed below. I'll probably have a worksheet or two, I'm sure. So make sure that you get lots of practice.